There are a lot of good things in the quiz, a lot of bad things. A lot of you are mixing up the two words, voltage and current still. And that's what I was worried was happening, so I wanted to do that quiz to see if that was happening or not. So we need to work on differentiating between what voltage and current are and how those rules are different. Everything we're going to talk about all comes back down to Kirchoff and his two rules that we've talked about up to now. So let's draw the first two questions. The first two questions really are the most important two questions on the quiz. If you understand those two, everything else will eventually come into play. Question 3 was probably the hardest of the questions, just because it required to be very intricate and you had to understand really everything we've done to understand that question. But most of you did the easy part of question 3 correctly. The hard part, most people did not do correctly. We'll go over that today. So, Kirchoff gave us two rules. What were those two rules and what were they related to? Anyone remember Kirchoff? Yes, let me show us one of them. Good, so if we add up all the changes in V around the loop, that should equal 0. Can someone put that into layman's terms for us? Besides saying the sum of the voltage drops equals 0, what does that mean to me? What does a proton have to do as it goes around the circuit?
Lose all potential energy.
Good, so it's going to lose all of the energy it got from the battery. Whenever what loop it takes, what path it takes, it's going to lose all the energy. Now it's important to us in some cases now, we have to start identifying the different loops in the circuit. Some of you aren't really doing that, and then you're getting confused and coming up with the wrong results. Your reasoning is kind of solid, but you're not using the idea of loops very effectively. So, in this circuit on the left, this was question 1 on your quiz. How many loops are there in that picture? 2. There's 2 possible paths a positive charge would take through that circuit. It would either do this, or it's going to do that. Will a charge ever do some kind of ziggy-zaggy thing like this?
No.
No, a charge will not make a figure 8. Once it's down, once the charge gets here, it's going to see the bottom of the battery. It's going to be like, holy cow, I'm almost home, and go that way. It's not going to go, okay, I'm going to go back up the hill for fun and come back around like this. It's not going to do that. So it's only going to go through one of those two loops. That's Kirchoff's voltage rule, loop rule, whatever you want to call it. What is the other of Kirchoff's rules? Deals with currents, conservation of charge. It was based upon the conservation of charge. And what does it tell you? It has to do with junctions. What's talking about a junction in terms of current and a junction? Any thoughts on that? Could you guess what it might be? It splits. Very good. The word split I would be careful with unless you know what you're actually saying here. But Kirchoff's junction rule told us that all of the current entering a junction has to also leave the junction. So for example, if we knew whatever current I1 was coming into this junction, and we knew there was a current I2 and a current I3 leaving the junction, we should be able to say that the current going in equals the sum of the two currents going out. That should hopefully make sense, and this is why it does to me at least. If I know, for example, that if I was looking right here and I knew that I saw 3 coulombs passing me every second, and they were going to go down to some junction where they're going to split, if I started counting here and here, I better see, in some fashion, like 2 coulombs per second here and 1 coulomb per second there, or some other combination of those. Otherwise, I somehow lost a charge somewhere in my circuit, and that's not going to happen. You can't lose a charge somewhere magically in your circuit. And so, however many charges per second enter a junction has to be equivalent to the charges per second leaving the junction. And then back down here again, it better be 3 coulombs every second, or else something very, very odd has happened. That can't happen. To be very, very clear about that. So that's Kirchoff's junction rule. That wasn't as important on this quiz, but it's an important one for us to know. Well, back of it was maybe. The back of the test. Question about Kirchoff's two rules before we go into the actual answers. So those are the basis of everything you could answer on this test. You did not need to know anything else besides maybe Ohm's law to answer these questions. So let's erase this stuff. All right, back to the screen. So we have this guy here. We have a loop we know that goes around this way. How many volts was the battery? 15, right? Is that correct?
Yeah.
15 volts. So I know that there's a 15 volts or 15 energy units the charge is getting when it leaves the battery. As it goes around this loop here, how many volts does it need to lose as it goes through that loop? 15. How many objects are there in that loop taking energy away from the charges? 1. So this guy here must be taking up all 15 of those volts. That's about all there is to say about it. That would be question A. Then I could find the current. I know these were all 10 ohm resistors. So I know that current should be voltage over resistance. That's Ohm's law. So 15 volts divided by 10 ohms should give me 1.5 amperes. Questions? Okay, sweet. So now we're going to go around the outside loop. How many volts do I have to lose going around? What's wrong?
I didn't hear a question about the first.
I know, I want to know what the question is.
I just spaced out.
What's the question? Go ahead.
I just don't get why it's 15.
Try 15 volts?
Yes.
Okay. Do you agree that as I go around this loop, all the voltage has to be lost?
Okay. Well, what about the second one? I thought we just said how much goes into the jump.
That's currents. And that's why I want to ask that question. That's the problem a lot of you have right now, is you're confusing the voltage and the current. The current follows the junction rule. That's why there's I. I is the symbol for current. I stands for intensity, which is the current. And the voltage is a different thing. The voltage is the energy. There's two different quantities that we're dealing with there. So, going around the outside loop, how many volts does the charge have to lose going around the outside loop? Still 15 volts. So the kind of the key idea here is that if these two branches are in parallel, from this point to this point, and from that point to that point, both of those paths have to use up all the voltage. So on this one, we only have one thing taking the voltage away. Over here, we still have to lose 15 volts. How many things are there though? 2. Are they the same thing? Yeah. They're both 10 ohms, right? So we can then say these are both going to take away 7.5 of those volts. And then I'll just add the 15. Yes?
So if it goes, so if it's going to the second part of it,
The outside branch.
yeah, wouldn't none of the electrons would go to the first one?
There's going to be thousands or millions of individual electrons going through the circuit. There's going to be, electron 1 might go through branch 1, electron 2 is going to go through branch 3, but neither electron will go through both branches. Each individual electron or proton is going to go through just one of those paths.
Okay.
One's going to pick one or the other. Okay? So both will get charges through it. This one's going to have the charges. We're going to find out going through it faster. They'll get more charges than that one does, in a sense. So I know now this is the answers A, B, C, and E, 7.5 volts for each of those resistors. Can I find the current to those resistors? Yes, because I still know that I is V over R. They're both 10 ohm resistors. It's going to be 0.75 amperes for both of those.
What if the resistors weren't the same and how you figure out the voltage by proportions?
You can, the shortcut way would be proportions. The official way is we do this every day. I think they make these like loop equations. Technically, this is how we should be doing it, but since they are all the same, we can kind of cheat in our heads. I mean, if this was like a 10 ohm and a 20 ohm resistor, I could probably pretty simply say it was 10 and 5. But if as it gets more complex, you'd have to rely back on your actual mathematical. Yes. But it will break proportionally in the end of it.
So voltage gets split